The James Webb Space Telescope, or JWST, has been sending back breathtaking images from the cosmos since its launch. It is the most powerful telescope ever built. JWST allows us to peer deeper into the universe than ever before. Its mission is to unravel the mysteries of the early universe, but it's also helping us in the search for life beyond Earth. The possibility of finding alien life has always captivated humanity. Now, with JWST, we have a tool that can scan the atmospheres of exoplanets. It can identify the molecules present. This ability opens up exciting possibilities. We may be closer than ever to answering the question, are we alone? JWST's observations of the exoplanet K218b have generated a lot of excitement. This planet is located about 124 light-years away from us. It orbits a red dwarf star. Initial studies of K218b suggest the presence of a molecule called dimethyl sulfide, or DMS. On Earth, this molecule is primarily produced by living organisms. The detection of DMS on K218b is a significant development. It hints at the possibility that life might exist on this distant world. However, it's important to approach this finding with caution. Scientists are still debating the interpretation of the data. We need more evidence to confirm the presence of DMS and its origin. K218b is classified as a super-Earth. It's about 8 times more massive than our planet. It orbits its star in the habitable zone. This zone is the region around a star where temperatures are just right for liquid water to exist on a planet's surface. The presence of liquid water is considered essential for life as we know it. K218b's size and location make it an intriguing target for the search for life. However, it's important to note that being in the habitable zone doesn't guarantee a planet can support life. Other factors, such as the planet's atmosphere and its geological activity, also play a role. Scientists are eager to learn more about K218b's atmosphere. The detection of DMS, if confirmed, would be a major breakthrough. It would suggest that biological processes might be taking place on this planet. However, we need to rule out other explanations for the presence of DMS before we can jump to conclusions. The search for extraterrestrial life is a meticulous process. It requires careful observation, data analysis, and interpretation. JWST's observations of K218b are just the beginning of a long journey of exploration and discovery. On Earth, dimethyl sulfide is produced by phytoplankton in the oceans. These tiny organisms release DMS into the atmosphere. It's a volatile compound, meaning it easily evaporates into a gas. DMS is part of the sulfur cycle, a complex process that involves the movement of sulfur between the air, water, and land. Detecting DMS on other planets is exciting because it could indicate the presence of similar biological processes. Of course, it's crucial to remember that DMS can also be produced by non-biological processes. Volcanoes, for example, can release DMS, so can certain geological formations. Scientists are carefully analyzing the data from JWST to determine the likelihood that the DMS detected on K218b is biological in origin. They're looking for other molecules that might support this hypothesis. They are also considering alternative explanations. The search for life beyond Earth is a quest for answers to some of humanity's most fundamental questions. It's a journey that requires both scientific rigor and a sense of wonder. The scientific community is understandably cautious about the potential detection of DMS on K218b. Extraordinary claims require extraordinary evidence. Scientists are carefully scrutinizing the data, looking for any potential errors or alternative explanations. Some scientists argue that the signal for DMS is weak. They believe it could be a false positive. Others point out that we don't know enough about K218b's atmosphere to rule out non-biological sources of DMS. This skepticism is a healthy part of the scientific process. It ensures that claims are thoroughly vetted before they are accepted as fact. The scientific method relies on testing hypotheses, gathering evidence, and subjecting findings to peer review. The debate over the significance of the DMS detection on K218b is ongoing. Scientists are planning follow-up observations. They want to gather more data. These observations will help to clarify the situation. Unraveling the secrets of distant worlds, JWST's instruments. The James Webb Space Telescope is equipped with a suite of advanced instruments. These instruments allow it to study the atmospheres of exoplanets in unprecedented detail. One of the key instruments is the Near-Infrared Spectrograph, or NIRSpec. NIRSpec can split light from distant objects into its component colors. This process is called spectroscopy. By analyzing the spectrum of light that passes through an exoplanet's atmosphere, scientists can identify the atoms and molecules present. Each molecule absorbs light at specific wavelengths, creating a unique fingerprint in the spectrum. Scientists can use these fingerprints to determine the chemical composition of exoplanetary atmospheres, including the presence of potential biosignatures like DMS. JWST's ability to perform high-resolution spectroscopy is revolutionizing our understanding of exoplanets. It's providing us with a glimpse into the atmospheres of these distant worlds, offering clues about their potential habitability and the possibility of life. TOI 421b, a clear view into an exoplanet's atmosphere. In addition to K218b, JWST has been observing other intriguing exoplanets. One such planet is TOI 421b. This planet is a hot Neptune, meaning it's a gas giant that orbits its star very closely. What makes TOI 421b particularly interesting is its clear atmosphere. Unlike many other hot Neptunes which have hazy atmospheres, TOI 421b's atmosphere is transparent. This clarity allows scientists to study its composition in more detail. JWST's observations of TOI 421b have revealed the presence of water vapor in its atmosphere. This finding is significant because it shows that JWST can detect water on exoplanets even in small amounts. The study of TOI 421b is providing valuable insights into the diversity of exoplanetary atmospheres. It's highlighting JWST's capabilities as a powerful tool for characterizing distant worlds. The challenges of interpreting data. While JWST's observations are providing a wealth of data, interpreting this data is a complex task. Scientists must carefully consider all possible explanations for their findings. They must rule out false positives and account for any uncertainties in the measurements. One of the challenges is that the signals from exoplanets are extremely faint. They are often buried in the glare of their host stars. Scientists must use sophisticated techniques to isolate the signal from the noise. Another challenge is that our understanding of exoplanetary atmospheres is still evolving. We are constantly making new discoveries that challenge our assumptions. Despite these challenges, scientists are making remarkable progress in characterizing exoplanets and searching for signs of life. JWST's observations are providing crucial data that is advancing the field. The quest for extraterrestrial life continues. The search for extraterrestrial life is one of the most profound scientific endeavors of our time. It's a quest that sparks our imaginations and pushes the boundaries of our knowledge. JWST is playing a pivotal role in this search. By studying the atmospheres of exoplanets, JWST is helping us to understand the conditions required for life as we know it. It's also helping us to identify potential biosignatures that could indicate the presence of life. The discovery of even the simplest form of life beyond Earth would be a monumental event in human history. It would transform our understanding of our place in the universe. It would raise profound questions about the nature of life itself. While we have not yet found definitive evidence of extraterrestrial life, the search continues. With JWST and other advanced telescopes, we are getting closer than ever to answering the age-old question, are we alone? Conclusion: a universe of possibilities. The James Webb Space Telescope is revolutionizing our understanding of the universe. It's allowing us to peer deeper into space and time than ever before. Its observations are providing us with breathtaking images and groundbreaking scientific discoveries. The potential detection of DMS on K218b is an exciting development in the search for extraterrestrial life. While further observations are needed to confirm this finding, it highlights the power of JWST as a tool for characterizing exoplanets and searching for biosignatures. The quest for life beyond Earth is a testament to humanity's curiosity, and our desire to understand the universe around us. With JWST and other advanced telescopes, we are entering a new era of discovery, an era that holds the promise of answering some of our most fundamental questions about our place in the cosmos. The universe is vast and full of mysteries. The search for extraterrestrial life is a journey into the unknown, a journey that challenges us to expand our horizons and imagine the possibilities.